Solving quadratics. Our objective here, solve quadratic equations using square roots, greatest common factor, factoring, and the quadratic formula. So what do we know coming in? Well, we know what a quadratic equation is. It is any equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Let's remind ourselves that ax squared plus bx plus c equals 0 is called the standard form of a quadratic. It's called the standard form. There's a 0 on the right side. We also know the zero product property that we're going to apply here. If a times b equals 0, then a equals 0 and or b equals 0. So we're going to apply that property to help us solve quadratics. What does it mean to solve a quadratic? When someone says, hey, solve this quadratic, what are they asking you to do? Well, what it means is you want to find the value or the values of x which satisfy the standard form. Okay, so here's the standard form. In other words, we want to make the left side equal to 0 because that will satisfy the standard form. This is done in 4 general ways. Okay? Way number 1, how about using square roots? This is a very popular method for solving a quadratic if you have no x term, if you have no linear term, or, which basically means b is equal to 0. So here's an example. I have a quadratic because my highest degree is 2. How do I solve a quadratic? I set it equal to 0. Okay? This one is negative 2x squared plus 10 equals 0. It's already set equal to 0. Well, notice we don't have a linear term. There's no x term. So we can use the square roots method, which basically means get everything over and then take the square root. So negative 2x plus 10 equals 0. Let's subtract 10 from both sides. Negative 2x squared is equal to negative 10. Let's divide both sides by negative 2. X squared is equal to positive 5. And now let's now take the square root of both sides. And let's remember, when we take the square root of both sides, we always have a positive and a negative answer. And so in this case, we have x is equal to positive or negative square root of 5. And I'll make a note here. Don't forget, positive or negative. Most people forget the negative. They think, oh, square root of 5. Well, I have 2 answers because the positive square root of 5, when squared, equals 5. The negative square root of 5 when squared also equals 5. So there are 2 possibilities here. So the square root method, generally used when I don't have a linear term. I can just solve for the square and then take the square root. Let's talk about the method of solving a quadratic. We factor out the greatest common factor. And in addition, we're going to apply the zero product property. This method is popular when there's no constant term, then when c is 0. Okay, so here's an example for this method. Solve 3x squared equals 6x. The highest degree is 2. It is a quadratic. We solve quadratics by setting them equal to 0. Okay, so 3x squared, I'll subtract 6x from both sides. And now I am in the standard form. Okay, now you have this be 0. Well, here is, I can see there's no constant term. And I'll notice I have a common factor of 3 in both terms and a common factor of x in both terms. So I'm going to factor out the 3x, and I'm left with x minus 2 equals 0. Okay? Now I can apply the zero product property. If this times this equals 0, then either this, the first thing I mentioned, 3x is equal to 0, or x minus 2 is equal to 0. Well, if I divide both sides by 3, that means 0 is one of my solutions. If I add 2 to both sides, that means 2 is one of my solutions. So for this quadratic, I solved it. X is equal to either 0 or x is equal to 2, and both of these will make that a true statement. Okay, let's do a couple more examples. We've got 2 more methods. Let me get my notes together over on this end of the camera. Okay, let's talk about solving quadratics using factoring the trinomial. Okay, I think my paper's a little bit crooked. I don't know if I can't always tell precisely, so if it is, sorry about that. Okay, we're going to factor the trinomial into the product of 2 binomials, and again, we're going to apply the zero product property. This is used if the quadratic is factorable. So you need to determine that. Is this quadratic factorable or not? I think I lost my, am I clear? I am clear. Okay, so let's see. I have a second degree as my highest. This is a quadratic. How do I solve a quadratic? I set it equal to 0. So I'm gonna move the minus 3x over here and write it with the x's first. So x squared plus 3x minus 18 equals 0. Okay, I have all terms, so I can't use the square root. I can't use the square root method, and I can't use the greatest common factor method. Is this factorable? Well, factorability means you're looking at these 2 pieces right here, the b and the c. Okay, and so we're saying factors of 18. 18 is 1 times 18. 18 is 2 times 9. 18 is 3 times 6. Is there any way that I can add these numbers, positive, negative, and get a 3? Well, there's no way with 18 and 1. There's no way with 9 and 2, but 3 and 6 works. Okay, so I'm going to factor it. I know I have x's, because I have only 1x squared. This is a popular method, by the way, when you only have a 1 in front. This is most popular to think about this with a 1 in front. Okay, because x times x is the only way to get x squared. Okay, let's take a look at the 18. I know I'm going to use 3 and 6. And I wrote the 3 here and the 6 here. You can put the 6 here and the 3 here. It's perfectly fine because it's not going to affect these single x's. I need a positive 3 and a negative 18. So I need a positive 6 and a negative 3 down here, because the product of these two, when I FOIL, is negative 18. Positive 6 and negative 3 is positive 3. So there I'm factored. And now I'm going to apply the zero product property. If something times something else equals 0, then either something is equal to 0 and or something else is equal to 0. So x minus 3 equals 0, or x plus 6 equals 0. This one says that x can be positive 3, and this one says that x can be negative 6. Okay, factoring a trinomial, again, it's generally, for most people, you want to have a coefficient of 1 for your x squared term. When it's a 2, a 3, a 4, or a 5, things get a little bit trickier. It's still doable, they just get trickier. And then you need to be checking it, and you want to kind of be checking it mentally. Is it factorable? If it's not factorable, this method does not work. But you can usually do a pretty quick check. 18, 1 times 18, 2 times 9, 3 times 6. 3 and 6 give me a 3, factorable. Okay, but it has to be factorable in order to use the factoring method. All right, the final method is the quadratic formula, and no matter what, it can always be used in every situation. So if you're not good at recognizing the square root method, you're not good at recognizing the greatest common factor method, you're not good at recognizing if it's factorable or not, like in number 3, no matter what, the quadratic formula always gives you the solution. So you can use it anytime you want, but you have to remember the quadratic formula, okay? Which is x is equal to negative b plus or minus the square root b squared minus 4ac, all of that over 2a. Okay, and again, use anytime you see a squared term as your highest power, you know you have a quadratic. They can all be solved by using the quadratic formula. So let's take a look. This is our a. Notice we're already in general form. And that's how you solve a quadratic. Put it in general form by setting equal to 0 and then using one of these methods. That's your b and that's your c. So x is equal to the opposite of b. I can do that in my head. The opposite of negative 6 is positive 6 plus or minus the square root b squared. I can do that mentally. Negative 6 squared is 36. And I can't do the rest mentally, so I just write it down. Minus 4 times a times c, all over 2 times a. Well, a is 2. I can do this mentally. If I'm correct, 2 times 2 is 4, okay? And I'm noticing in my practice, when I did this myself, I didn't do it correctly, so I gotta watch myself now. So now, let's simplify what's underneath the radical, called the radicand. So this is x is equal to 6 plus or minus. Well, 36 minus 8. If you want to get out a calculator, you can use a calculator, but I think this is the square root of 28. I think 36 minus 8 is 28. All of this over 4. Okay, well, let's remember our simplifying our roots. The square root of 28 is equal to the square root. The largest perfect square factor is a 4. It's 4 times 7, which means it is 2 root 7 when I simplify it. So x is equal to 6 plus or minus 2 root 7, all over 4. Okay, well, this is a common denominator. It applies to this and this. So I'm going to rewrite it with a common denominator. So I have 6 over 4 plus or minus 2 root 7 over 4. And now I can take out the common factor, which is 2. So x is equal to 3/2 plus or minus root 7 over 2. Okay, now if you want to make the common, we could also write this again. You could put this a common denominator. You could say 3 plus or minus root 7 over 2 this way. Okay, we also recognize I have 2 solutions. And so my solutions are 3 plus root 7 over 2 and 3 minus root 7 over 2. Notice I have a square root of a non-perfect square, so these are the exact answers. These are not decimal approximations. So obviously, these answers you wouldn't have got from factoring. You would have had a hard time coming up with these answers. And so the quadratic formula is always used when the answers are not nice and neat. These answers, of course, are not nice and neat. So solving a quadratic formula always works, but you might try first simpler methods such as factoring the trinomial, using the square root method, or taking out the greatest common factor.